Assalamualaikum. My name is Aisha Akhtar. Now I'm going to present a paper presentation whose name is Design Challenges of Multi-UAV System in Cyber Physical Applications, a Comprehensive Survey and Future Directions. Start from the abstracts. What is that? That is the unmanned aerial vehicles, whose acronym is UAVs, have recently evolved rapidly to enable a wide range of novel applications that have the potential to radically alter the way cyber physical system, that means CPS, that's are designed. The main advantage of using UAVs in CPS application is their exponential features, including their mobility, dynamism, effortless, including their mobility, uh, deployment, adaptive altitude, agility, adjustability, and effective appraisal of real-world function anytime and anywhere. Furthermore, from the technology perspective, UAVs are predicted to be a vital element of the development of advanced CPS, highlighting key and versatile aspects that span the coverage and tracking of targets and infrastructure objects, energy efficient navigation, and image analysis using machine learning for fine gain CPS applications. Then the introduction part. What is that? That is the popularity of multi-UAVs can be linked to important characteristics like as mobility, adaptive altitude, easy deployment, flexibility, and changeable uses. Practical applications that use the multi-UAVs to collect sensor data are significant because they take advantage of the benefits of wireless sensor networks, such as low-cost, efficient sensor with no deployment overhead and access to a variety of data types such as temperature, humidity, and the geographic information. The core of CPS is the integration of ubiquitous computing systems and communication services. Within the paradigm of CPS, an interface between sensor devices, network users, or applications either with each other or with their surroundings is systematized by communications and computation cores. Applications of CPS are enormous, including medical systems, manufacturing, automation, transportation systems, and the aviation systems. So the technologies like satellite remote sensing and the distributed camera sensor networks are used in many applications to provide large scale and localized monitoring respectively. However, as shown in figure 1, both technologies provide two extremes for surveillance with respect to accuracy versus intrusive deployment and maintenance. SRS provides slow, large-scale monitoring, while the CSNs require widespread deployment and constant human intervention for setup and maintenance, which may not be feasible, particularly in harsh environments. Similarly to surveillance applications, UAVs technologies have progressed significantly in several applications in the past decade, making the commercial and civil application feasible and the compelling. Now, the next part, background and related works. There have four systems. What's that? These applications will be used in the remainder of this survey to map and identify the design challenges of UAVs within the CPS applications. Number A, UAVs systems as shown in figure 2. UAVs can categorize into different categories based on their size into micro and nano UAVs, small UAVs, medium UAVs, and large UAVs. The next part, cyber physical system. That is the main success of CPS in real world application is attributed to their reliability and predictability. Number C, the multi-UAVs in CPS applications. So that is the transportation application, construction and infrastructure, inspection applications, surveillance applications, delivery of goods applications, wireless and cellular systems applications, medical as well as the health systems application, also smart grid. Number D, the related service and key contributions. A thorough discussion on the main challenges in the designing multi-UAVs, presenting lesson learned, qualitative and quantitative comparative studies, and the presenting future research direction. In this paper, third section, that is the architecture and the design challenges of multi-UAVs systems. In these sections, they depict the major architecture and design, the challenges and issues for multi-UAVs system, motivating and highlighting the trade-offs for distributed versus centralized processing and the control of UAVs. Now, section 4, camera and target coverage of multi UAVs systems. So applies to surveillance application, but covers more professionally is referred to as the state when there is at least one camera viewing the target with acceptable quality. Technically, the area monitored by camera is called the field of view or angle of view, which is shown in 0 or 360 degrees. The triangular area in figure 6 depicts the FOV of a camera sensor node, where is called the FOV vertex angle is defined as the camera orientation, and the R minimized and the R maximized at the minimum and the maximum sensing range of the camera and respectively. So here I have three part, which is area coverage, target coverage, and the listen learn. So what is first area coverage? Depending on the number and the mobility of the cameras, the objective in this case may be to either minimize the number of fixed cameras deployed to cover certain area, or to minimize the time required to cover the area using the number of mobile camera to detect any events within fixed deployment, as well as the area scanning. Number B, target coverage. Fixed target coverage, point target are involves. Number C, listen learn. So what is that? That is the UAVs can be used for CPS applications to provide quick, low cost, or non-lasting visual sensing solutions that are the significant in real world applications such as border protection and the disaster recovery. Section 5, path or trajectory planning in multi-UVS system. There have uh, three part. What is that? That is number A, collision avoidance, B, swarm formation, C, energy planning, and the UAVs energy profiling. Number A, planning the paths that UAVs go through to cover key areas and the object on site is very crucial to minimize the aerial mechanical energy consumed for navigation, while the ensuring that the UAVs can fly in an obstacle-free plan and avoid collision against each other. Number B, swarm formation. So the formation problem is described as obtaining a control algorithm that guarantees that several autonomous vehicles can uphold a particular formation while traversing a generalized trajectory and avoiding collision simultaneously. Number C, energy planning and the UAV energy profiling. There have consist of a few things, that is the collision avoidance, swarm formation, and the energy planning. This three part is consisting of these things. Then section 6, what is that? That is the image analysis and vision based techniques for multi UAVs systems. And number A, the multi UAV system UVS for visual monitoring of CPS. That is uh, multi UVS, that is the collection of data. Number 2, effective visual data analysis algorithms. And the number B, listen learn, as an intuitive representation of the object under investigation. Images are the most popular choice for UAV applications. Image analysis and vision based techniques are typically needed for target detection, localization, and the possibility target making. So in this section, identifying the requirements of CPS application and selecting the appropriate collection components, providing data collection strategies for multi-UAVs that allow effective collaboration among UAVs during the data collection, identifying the most informative views for data collections. Visual data analysis has been a research subject to for many years, and several image and video processing techniques have been proposed. Section 7 is networking and cross-layer design for scalability and secure communication multi-UAVs system. So above all, networking issues are another important aspect of multi-UAVs systems. This is in term could be divided into two main categories, namely wireless topology and the connectivity control and cross-layer design, and the quality of service of the MANET of drones. In this section, there are four parts. Number A, network connectivity and topology control. The primary goal of the sensor network community research is to save energy by scheduling activities while preserving connectivity and the area coverage at the same time. Number B, cross-layer design and the quality of service. However, the integration of cognitive or radio technology in UAVs poses many design challenges on antenna and multi-base collaborations. The issues on the coexistence of different networks and interference controlling among UAVs must be considered. Number C, safety and security. That is the important part in this section. The proliferation and the low-cost features of this drone pose attractions to many to deploy and use such drones in an unexpected manner that can pose privacy, safety, or security threats to other humans or networks infrastructure. Due to the wireless nature of UAVs and their implementation in open and wired areas, they are subject to be hacked and losing control easily, causing potential harm to people and the environment. Number D, lesson learned. Exploring the literature reveals that even when it comes to the security of UAVs, only a few researchers have focused on examining and addressing the underlying design security concern. In the future, more studies and solutions in this sector will be necessary. In this table or index sections depicts also the design problem and need for the UAV networks, connectivity, quality of service, and the security with the CPS applications. Section 8, that is flight controlling. The aim of designing fully autonomous flight controls is to be capable to operate in different environments and accomplish several required missions, which is essential to close the circle in CPS system through the controlling the UAVs as a result of environment dynamics. There have some few parts. Number A, linear flight controls. There have also subparts. This is the proportional integration derivatives. So PID automatically uses prices responsible adjustment to control functions. In PID, the controlling parameter is adjusted to tune the current state of the UAVs with the reference flight path and kept continuously tuning throughout the flights. Number two, the linear quadratic regular, that means the LQR is controlling algorithm that is work in a dynamic system through LQR is a control algorithm that works in a dynamic system to decrease the suitable cost function. Number three, H is proportional loop forming model method. The H is proportional loop forming method integrates the robust control into the classic loop forming methods. The method is designed to harness the advantage of the above two methods, particularly the solving optimization problem. Number B, nonlinear flight controllers. There have also some few parts. Number one, the sliding method control, which is the main benefits of using this approaches are its dynamic configuration, its sensitivity to distribute modeling errors and the parametric uncertainties and its good tracking. Number B, backstepping. The main concept of backstepping control method involves the partitioning of the controller tasks into several steps to process and gradually stabilize each subsystem. Number three, the feedback linearization. The feedback linearization control algorithm is designed to either completely or partly transform a nonlinear systems model into a linear one-by-one changing visible settings, in which the main purpose of the transformation is to enable linear control. Number four, adaptive control algorithm. Adaptive control algorithm is designed to uncertain or time-changing parameters with the system's variation. Number five, robust controlling algorithms. So it is designed to ensure satisfactory control performance with capable distribute range by using the unmodeled systems parameters. Number C, learning based method. The importance advantage of learning based control method is their ability to learn from real world scenario and behave accordingly. Number D, multi UAV control and multi UAV communication. Its four CPS applications are mainly designed and adjust with their interaction restriction in mind. Delays or interruptions in communication critically affected flight control system performance and highlighting the risks of collision among UAVs. The next part is future ideas and the motivation sections. So there are some few points that I will only include the name. Number A, distributed UAV architecture addressing multiple objects, the coverage and the tracking throughout vision-based detection, path and trajectory planning, network and cross-layer design, safety and security, machine learning. Now the last part is conclusion. What is that? That is the multi-UAV design. Difficulties in physical application have been categorized. Each has been elaborated on. Each of the problem difficulties and the solutions were studied in order to demonstrate how each of them affect the performance of the multi-UAV system. Finally, the future ideas, the motivations provided the reader with a promising outlook on the next generation of multi-UAV systems, addressing many issues such as scalability and decentralized architecture, wireless connectivity, and topology control in large UAV networks, coverage and tracking the unpredictable and dimensional targets, path planning, safety and security, and many more. Thank you so much.